Okay, so today we are going to talk about the sum and difference identities for sine and cosine. Okay, these are in your packet. They look like this. Because these are angles, I cannot just separate them. So this is going to be, I'll use what the book uses, u plus or minus v. So plus or minus means the top one goes with the top, the bottom one goes with the bottom. And it is sine u cosine v. If it's a plus, it's a plus. If it's a minus, it's a minus. That is true for sine. That's cosine u sine v. I cannot just split these up and do them separately. Okay. This is the identity. I'm not going to make you learn the proof. You just have to learn the identity and use it correctly. For cosine, it's a little different. This one, notice I'm writing minus or plus. It's because when it's cosine u plus v, it's minus. When it's cosine u minus v, it's plus. Okay, I am about to apply this. So we're going to use this to find an exact value of cosine of 15. And now we do not have 15 degrees on our unit circle. Did not mean for that to happen. Okay, so we're going to look here at our unit circle. 15 degrees is not on it. However, 45 and 30 are on it. And 45 minus 30 is 15. And we're going to do this with exact values here. Okay. So I can see that the cosine of 45 is square root of 2 over 2, and the cosine of 30 is square root of 3 over 2. So I'm just going to keep those noted and then go back to the whiteboard. So this is cosine of 45 minus 30. So cosine 45 times cosine 30, because u here is a 45 and v is a 30. You just have to get used to u and v. That's what's used a lot in calculus. This is a minus, so that means it's a plus here. Sine 45, sine 30. I suppose I should have noted both of those. But I can get both of those out of my unit circle. Cosine of 45, I know is square root of 2 over 2. Cosine of 30, square root of 3 over 2. Sine 45, square root of 2 over 2. Cosine of 30, or sine of 30 is 1/2. So when I multiply fractions, I multiply numerator and denominator. Square root of 2 times square root of 3 is square root of 6. Square root of 2 times square root is 2. 2 times 2 is 4. I got a nice common denominator. The cosine of 15 degrees in exact form is the square root of 6 plus the square root of 2 over 4. We're going to take a look at the calculator and verify this, okay? So let's see what mode I am. I'm in radian mode, so I need to go to degree mode here. And now I'm in degree mode, cosine of 15. I'm going to do my answer. Oops, it's not supposed to be a minus. To replace that, I'm gonna do second entry. Will give me my and I can see that the cosine of 15 is there. I'm going to show you here for a second that the cosine of 45, if I don't use this identity, minus the cosine of 30, if I don't use the identity, that is not the same. Okay, so the identity becomes very important. We can see here that the cosine of 15 and the answer we got are the same. And the calculator is always a great way to check your work on these things. Okay, keep your formula packet out because I'm not going to keep that sum and difference identity at the top. That was example 1. This is example 2. We're going to confirm we learned before this identity. That's also a little higher on your identity sheet. Equals sine theta. Okay, cosine pi over 2 minus theta. So we'll do this one. We're going to use the identity on this. Cosine pi over 2 times cosine theta minus, this is a minus, so it's plus sine pi over 2 sine theta. Well, the cosine of pi over 2 is 0. And the sine of pi over 2, again, getting these off my unit circle, cosine of pi over 2 being 0, it's the x-coordinate, pi over 2 being 90 degrees or straight up. Sine of pi over 2 is 1. 0 times cosine theta is 0. 1 times sine theta is sine theta. We can also do this with a sine identity. And that is sine pi over 2 cosine theta minus cosine pi over 2 sine theta. There's my equal sign. Not coming quite straight down, but 1 times cosine theta minus 0 times sine theta equals cosine theta. Oh, hey, look, that's what it's supposed to equal. We're going to do it with some other things. So this one, example 3, says write each of these as a single sine or cosine, and then we'll simplify it. So here we've got sine 22 degrees cosine of 13 degrees plus cosine 22 degrees. Oh, example 3, I forgot to write that. Sine 13. This looks like the sine sum identity. Sine 22 plus 13 equals sine of 35. That's part A. B, cosine pi over 3, cosine pi over 4. This one's a plus. Sine pi over 3, sine pi over 4. That looks like a cosine. And because it's a plus here, that means it's a minus in this one, cosine being the opposite. Now, pi over 3, I need a common denominator, which is 4 pi over 12. Common denominator is 12. So I need to multiply the pi over 3 by 4 on top and bottom, and the pi over 4 by 3. giving me pi over 12. So that one, we recognize what identity is, we put it together. And then with these, when we're in radians, you have to add the fractions. I don't know why I wrote D, no C, and put them together. My last one, oops, well, I guess the order doesn't matter that much. This actually looks like, it's kind of like a cosine, but it's a little backwards. I'm not used to it in that order. And we'll put it, doesn't matter if I have the 2x first or the x because I can multiply in any order. Okay. I'm going to factor out my negative so that I have cosine supposed to be positive for this identity. And that makes my one in the middle negative. So this looks like a cosine sum with having the minus. And then I just add x plus 2x and get 3x. I'm going to use this to prove a couple of formulas. So again, using the sum formula, and these values, sine of pi and cosine of pi, I can get those numbers out of the unit circle, cosine of pi being -1. My sine x and cosine x, I can't do anything with. Sine of pi being 0. And -1 times sine x is negative sine x. 0 times cosine x is 0. I'm done. This was example 4. I'm going to prove one more. Okay, so I'll use my cosine identity. Times cosine 3 pi over 2 minus with sine. And then I get here cosine x times cosine 3 pi over 2. Cosine 3 pi over 2 is 0. Sine 3 pi over 2 is -1. Two negatives make a positive. And I'm left with just sine x. There is a sum and difference identity for tangent. A lot of times, though, it ends up being harder to use than just doing sine over cosine. Because for tangents, remember, you don't get the values on the unit circle. If you know the tangents, though, this one is easier. But if you don't have those memorized, which I don't have most of those memorized. It ends up being easier, like the example we're going to use, just to do. So keep in mind the bottom, the signs are flipped. The top, the signs are the same. So example 5 asks us to do a tangent. It asks us to do this. Unless you know tangent of 3 pi over 2, it's probably easiest to just do sine of cosine. I could tell you what tangent of 3 pi over 2 is, but that's besides the point. Sine. Oh, these are all theta. So sine, I'm going to use the sum identity, or the difference identity, I guess. And then I'll use the difference identity on cosine. Okay. So now my sines and cosines of 3 pi over 2. Cosine of 3 pi over 2, I look down at my unit circle, find 3 pi over 2, and that's 0. Sine of 3 pi over 2, I look down and I find that that's -1. Oops, I totally miswrote this. That shouldn't be sine theta, that should be cosine. Or that shouldn't be cosine theta, that should be sine theta. So looking back my line, cosine theta, cosine 3 pi over 2 plus sine theta, sine 3 pi over 2. Sine 3 pi over 2 again is -1. The first part of this fraction is all 0. I got two negatives here, times cosine makes a positive cosine theta, a negative sine theta. Cosine over sine, I got one negative. Cosine over sine is cotangent theta. Okay. That is my sum and difference identities.